Number 6, this question is about reciprocal graphs. Reciprocal graphs are the special kind of graph where we have the asymptotes. And this graph has the asymptotes at x equals 0 and y equals 0 for the simple, or I'm actually calling them apparent functions, k over x. Depends on the k value, depends on what we have on the numerator. The graph can look like this, where k is positive. So as long as x is positive, y will be positive then. So the graph is something look like this. So the x-axis and the y-axis both are the asymptotes. There's no intersection. As well as the x negative, that will be basically going to give us the y negative as a positive divided by negative. So the other branch, or the other part of the graph, will be over here, and the parent function is something look like this for k greater than 0. That's a reciprocal graph, k over x. So you already guessed, when k is less than 0, that means whenever x is negative, since k is 0 less than 0, right? X is negative, negative divided by negative will give us positive, so it will be defined in this part. So similarly, as long as x is positive, negative k, which negative divided by positive will be negative, it will be somewhere over here. So try to sketch your graph properly as much as you can whenever you are sketching the graph. So those are the graph for the parent functions. K is positive, k is negative. So for the graph k over x, you might gonna have here k over x squared. You should also know how the graph looks like. It's very easy to identify this as well. So since this question is about just k over x, there's a shift over here. I'm going to be working on this anyway. So that's basically k over x. That's a linear one. So that is going to be look like one of this. Okay, so let's dive into this question. So the question tells us we need to sketch y equals to 1 over 2 minus x. Okay, so I'm going to be writing this equation first as negative. Let me just write all the details. 1 divided by, I put the negative sign in front of the expression 2 minus x, and I write the expression as x minus 2. So I can easily see the shift. So I can easily see this shift is going to be shift to the left or shift to the right. So that's basically going to be decided in this way. And I'm also going to, using this method, I'm also going to decide whether the k is positive or negative. So am I going to sketch the graph like so or like so? It's going to be after that. Okay. So if I take this negative sign to the top of the fraction, that will be negative 1. That will be a negative 1 divided by x minus 2. Alright, so k is negative. So I'm going to write down here k is less than 0. And we're going to be talking about the asymptote now. So there is a y intersection, obviously, because x can be 0, but you know, in the reciprocal functions, if you just studied this topic before, you know that in the reciprocal graphs, or let's say fractions, the denominator cannot be 0. So because we are not able to divide by 0, that's simple. Denominator is going to be 0 only x is equals to 2. So we are actually going to say x cannot be 2. It's actually said, they said it on the top over here. If you look at this question, they said x cannot be 2. That's basically where we have the vertical asymptotes. Since x cannot be 0, there is this value, or let's say the output or range, or what you're gonna call it, like the y value, I'm gonna say, is undefined at 2, because if you take x2, it's like negative 1 divided by 0 is undefined. Okay. So this is where we have the problem. Alright, so k is less than 0, and then x cannot be 2. Let me actually write this here. X cannot be 2, where we have the vertical asymptote. Okay, so what I'm going to do is I'm going to be sketching first the Cartesian plane, xy plane. Okay. So this is a y-axis, this is an x-axis. Try to be accurate as much as you can when you're sketching the graphs. So I'm going to be sketching the vertical asymptote. So like, let's imagine that's 2 somewhere over here, and this is what it look like if I sketch it. Okay, so that's point is 2. All right, so that's where x is undefined. So the graph is going to be something look like this. Let me put the tail over here, or something look like this. Okay, so I mean something look like this, not all of them together. Something look like this. We're going to be deciding this just looking at the k value. So the k value, the k is less than 0, which is this case, and the graph of that parent function look like that. Okay, that means if I sketch this graph, it is going to be, let me use a red color maybe, that's going to be look like this, I'm sure. Okay, so that's going to be look like this. Actually, let me actually put this part a little bit closer to x-axis, because that's never reaches, there is no x intersection. So I'm going to talk about why there is no x intersection, but there is a y intersection. Okay, so how do I know there is a y intersection, or how do I know there is no y intersection, or x intersection, not x intersection, and so on? Okay, I'm going to use a black color for this. Okay, so it's actually a part of our question to find, look what they say, equation of a vertical asymptote. We're going to be writing this, and then the coordinate of intersection of C with the y-axis, like there is no x intersection. We know it from the question also. Okay, so I'm going to be saying, all right, so then the equation of the, let's say, vertical asymptote is just going to be x equals to 2. Okay, and this is the dashed line passing through 2, and the coordinate of the intersection with the y-axis, I'm going to be finding this also, like this point, whatever this is, I'm going to be finding it. Okay, so let's take our function. Like function is, I'm going to use a black color for this, y equals to just a simple itself, like 2 minus x. So this is it. What I have to do is I need to find y intersection. So to find the y intersection, we know that we have to set x to 0, right? So if I set the x to 0, that means y is going to be 1 divided by 2 minus 0, which is a half. Alright, y intersection, there is a y intersection obviously, as you can see, and that's a half. Okay, so coordinates of that is going to be 0 and a half. Okay, that's pretty simple to find. But what about the x intersection? Do we have an x intersection? To find an x intersection, this is part of our solution, or part of sketching the graph. To find an x intersection, we have to set y is to 0. So we know this from IGCSE as well. How to find the y intersection, how to find the x intersection. To find the y intersection, we need to x intersection, we need to set y 0. So 1 divided by 2 minus x, that's equals to 0, and we can write the 0 as a 0 over 0. Okay, so if I try to cross multiply this, is simply the simple logic, let's say, to find the solution for the equation. If I cross multiply that, it basically tells us 0 equals 0, which there's nothing to do with this. Or if you don't really cross multiply, okay, if you think of like this one as there's a 0 over here, and then you basically want to write it as 2 minus x equals 2, you just basically interchange this as 1 divided by 0, where 1 divided by 0 is undefined. That means 2 minus x is undefined. There's no x intersection. You can just conclude with that. Okay, there's no x intersection. I'm going to go just a little bit of this graph one more. So how did I do that? Just a little bit. Okay, I wrote this graph as, equation as 1 over 2 minus x, as negative 1 over x minus 2, to see a shift, or to see easily a vertical asymptote, let's say, and as well as to identify the k, like where basically depend on the k. We have two different type of graph. K greater than 0 graph look like this, k less than 0 graph look like this. It's better to write in this form to not to confuse the k value. Okay, but if you are able to do it from that one as well, you're more than welcome, okay, to do it. Then I decided the k is less than 0 as I look at this -1, and I decided, alright, so basically x minus 2 equals 0 and x equals to 2. So basically x cannot be 2, and that's a vertical asymptote, and we just look like this. Alright, so what happened is you just shift this graph 2 units to the left. So you can just imagine this for a while. If you shift this graph 2 units to the left, I said the left, 2 units to the right, you're gonna say that, all right, there will be an there will be a y intersection, because you're just literally moving it to the right. Yes, so this is somehow we're gonna intersect with the y-axis, and there will be no x intersection because there is no x intersection over here. And when I shift it to the right, there will be no x intersection as well. Okay, so and then you just decided the graph is going to be look like this, and then don't forget the requirements as like coordinate of the intersection of the c with the x-axis and etc. requirement that you need to be showing on your graph to get the full mark. Okay, so that's it. We are done with this question. And question number 6, part B. In the next part of this question, they say the straight line L has an equation y equals to kx minus 4, where k is a constant, given that L cuts C at least once. Show that k squared minus 5k plus 4 greater than or equals to 0. Find the range of possible values for k. So obviously, after showing the equation in terms of k is something look like this, like we're gonna using many things for that actually, and then we need to be showing, all right, that the k value is solving the quadratic equation, a quadratic inequality, because we're gonna be solving this quadratic inequality. That topic goes into simultaneous equations on graphs. You might already know this, and basically for a pair of quadratic equations, let's say, or sorry, pair of simultaneous equations, I'm going to be writing this, show you that's actually a simultaneous equation. And if two equations, when I rearrange them somehow, produce a quadratic equation as ax squared plus bx plus c, which means this statement will be true, or one of them will be true, let's say, if the discriminant of the final form, the produced form, gives us b squared minus 4ac less than 0, two real solutions, or equals to 0, one solution, or that's my bad actually, that must be a greater than 0. That must be a greater than 0. If that's a greater than 0, two real solutions, equals to 0, one real solution, less than 0, no real solution. So because under the square root, there cannot be a negative number. For you, for now, it can actually be, but we are not learning it. Neither on ASA level, only it's in the further pure mathematics. Okay, so let's just apply that. Remember, we had that equation on the top as y equals to 1 over 2 minus x. I'm going to be taking that. Y equals to 1 over 2 minus x. And there is one more equation they are giving us as kx minus 4. So that gets kx minus 4. Okay, so as you can see, that's a simultaneous equation. They have an intersection, which means they have the common x point and they have a common y point for this both graph at some point, like some intersection. Like imagine is something. If I roughly sketch the first one and the second one, there's an asymptote over here, let's say, and imagine that graph is something look like this. Imagine, or I don't know, there's some different forms it can be. Actually, we can look at this at the end in the decimals, just knowing the knowing the k values. Anyway, okay, so how do I do this? It's like simultaneous equation. How do we solve the simultaneous equation? Since from grade 8, I guess, it's just either we use a substitution method or elimination method. So the elimination method wouldn't work here because the kx and then 1 minus 2 minus x can be working, but will be hell a lot working. Instead, what we do is, since that intersection has the common y point, so that y's can be the same, that means I can equalize these two equations. 2 minus x, that's equals to kx minus 4. Okay, so rest of this is going to be a pure algebra. You have to be very careful what you do in each step, otherwise your equation wouldn't be the same as the equation they gave us to show, and then you need to start your work again or to recheck every single step that you have done to find your mistake. So be very careful, okay? So what we do is we're going to cross multiply this. In the cross multiplication, you might think that imaginally like there's a 1 over here, and then you are going to be multiplying 2 minus x by 2 minus x by kx minus 4. That's going to be equals to 1. Expand it carefully as 2a kx minus 8 minus kx squared, and then the plus 4 equals to 1, plus 4x equals to 1. I'm going to be double checking that. 2kx minus 8 minus kx squared plus 4x equals to 0. Okay, so what do? I just put this x squares in front of that. Let's say like the first one, this is the leading one. And then I'm going to be putting this 2kx and then the 4x together, and then there's a minus 8 and there's minus 1 equals to 0. What I did is just took this 1 to the other side. Okay, so the next step is to I am going to be multiplying everything by -1. You don't have to necessarily do that, but I'm actually going to multiply by the -1 after I actually factorize this 2kx plus 4x. Okay, I'm going to be writing this as it is almost, just taking the x as writing 2k plus 4 minus 9 equals 0. And let's multiply everything by -1. That gives us something look like this, plus 9 equals 0. As I'm saying one more, be very careful. Okay, so and then decide what's your a, what's your b, what's your c. A is equals to k, and b is equals to negative 2k minus 4, or you can actually write this as just a negative 2k plus 4, and then c is going to be 9. Remember what they said on the top? They said the L over here, the L, which is that line, cut C or met with the graph of C at least once, and this is two solutions or a one solution. That means it's going to be greater than or equals to, because they say at least 1. So I'm going to be solving this as a b squared minus 4ac greater than equals to 0. That's what they want, okay, at least 1, which tells us 2x plus 4 all together squared minus 4 times a, which is k, and minus times c greater than equals to 0. And then if I square this, I don't need to write the negative sign over here. Let's write it as 2 plus 4 altogether squared minus 36k greater than equals to 0. And that's going to be 4k squared minus 16k and plus 16 minus 36k greater than equals 0. And then you're going to be solving this as, just like simplify the case, 4k squared, is this going to be 20k and plus 16 greater than equals 0. So if I go back to what they have their k squared minus 5k plus 4, and if I come back to mine, it doesn't look like it, but it's actually the 1 if I divide everything by 4, because each terms in this equation is divisible by 4. So if I divide everything by 4, I'm going to have k squared minus 5k and plus 4 greater than equals 0. That's completely matches what they have if you go and look at back. Okay, so If I do this, presumably I have 3 or 4 marks. We get a look at the mark scheme for this. Whole this process is actually going to give you a lot mark. The last part, which if I actually number this is a part first, and on the part second, in the part second, we're going to be finding the range for the k, and there are a few different ways to solve quadratic inequalities. That you can use the graph, or the method I'm going to be showing you here is also a well-known. I hate to sketch the graph of the functions. Instead, I use this method. So I'm gonna write this method with the red one, red color. Okay. So just we have the quadratic inequality. I'm going to be taking this quadratic inequality, just something look like a quadratic equation, and I'm going to be finding the roots. Okay, so the finding the roots of quadratic equation is just you can do factorize it, or use the quadratic formula. It's completely up to you. X minus 4, x minus 1. Sorry, k minus 4, k minus 1, k squared minus k minus 4k plus 4, just double checked it. Okay, so and then find the roots. So how do you solve the factorized quadratic equation? Equalize both into 0, k minus 4 equals to 0, or k minus 1 equals to 0, where k is 4, where k is 1. Okay, so what do you do after finding the solution is just put a number line, and obviously that's a number line. That means it has to be, the roots has to be sketched in an order. There's a 1 over here and there is a 4 over here. Okay, divide this into a sections. Put a vertical line on 4 and on 1. If you have more than 2 or 5 solutions, so you're going to be put a 5 vertical lines there. Okay, just dividing this into a sections. So that we have this part is where we have the numbers less than 1. This part is where we have the numbers between 1 and 4, and this part where we have the numbers greater than 4. Since both 4 and 1 included, let's just highlight it. It just like those are included, let's say. Okay, so what do I do next? I choose a number. It's either in between 1 and 4, or less than 1, or greater than 4. So I'm going to be taking the number which is less than 1. I know there is a 0 over here somewhere, right? So why do I choose this? Is because it's easy to substitute and see whether the equation is positive over here or not. So I choose the 0. Okay, so then I take the 0 and write instead of k in the equation. So the equation is k squared minus 5k plus 4. If I put a 0, that will be 0, that will be 0. There will be a 4 on the left, which 4 is a positive. I'm going to put in a plus sign over there. That means the equation, no matter what number I choose from this range, is going to be positive. You can actually choose -1, -10, -1,000,000. You can check it with your calculator. So it's easy. It's basically okay or enough to find one point or the sign for the one section, and then the rest will follow with the pattern. As if this is positive, that will be negative then, and the one comes after in the other section will be positive. So the pattern goes like this. You find a 1, and then just each section just change the sign. Positive, negative, positive. Okay? You can actually, to check whether this is positive or not, you can actually take 5 or 10 or any number bigger than 4, write in this equation and check that's going to be positive. So what we found right now is the this inequality will be positive whenever k is less than 1 or k is greater than 4. So that means we need to be taking a solution k is greater than 1, or let's say k is I said greater than 1, less than 1, and the k is greater than 4. Okay. So, but remember this, we basically included the values 1 and 4. That means I'm going to put an equality sign there, less than equals to, or a greater than or equals to. Okay, so that will be the end of it. That will be the range of k values which this inequality or this equations or this simultaneous equation intersect at least one. All right, that's it.